Buenos dias, fecheritas. Today we're going to talk about section 4.7 and 4.8. And so, yeah, let's buckle up and get ready to roll. I still recommend that you take notes. Highly recommend that you take notes. It's going to help you in your learning process. Don't forget that throughout the rest of the lectures that are online. And the nice thing is that you can pause this, all throughout the lecture, and I'm going to tell you at times to pause, do some problems, and let you do them on your own. I'm not going to stop and sit here quietly and wait for you. You pause when I tell you to. Okay, so here we roll. What are we doing? Let's see, Diamond Dave, can you see me writing over here?
I can indeed.
All right, sweet,
Very
man.
rich.
And give us any feedback if these things are really hard to see or whatnot. We're doing our best. We're having World War Z out here in Rexburg, so we're in a bunker somewhere, hiding away from campus. So
With all kinds of toilet paper.
we do have a lot of toilet paper and lots of foods. So check it out. In section 4.7, I'm going to tell you right now that there is nothing new that you are learning in this section. We've talked about in section 4.1 and 4.2, we were covering the laws of exponents. Okay? In section 4.1 and 4.2, we're covering the laws of exponents. But the rest of everything that we cover in chapter 4 is all about polynomials. And so in section 4.3, we learned about the basics of polynomials. In section 4.4, we learned how to add and subtract polynomials. In section 4.5 and 4.6, we learned how to multiply polynomials. Okay, that's polys, okay? And that's what we've covered thus far in our lectures. And we went through all of this while you were back on campus. So, real quick here, what are we doing in section 4.7? We are reviewing all of this. I want you to open up your textbooks, if you would. I know I'm going to slip out of the camera now and then to take a quick look at the textbook, but I want you to open up to page 371. Okay, so if you need to pause and get that out, go ahead and open up to page 371 in your textbooks. So one of the things I want you to get here, in fact, we're gonna slip backwards to page 367. There he is again, your sexy author of your textbook. He loves pictures of himself working out and on that treadmill of his. We've got too many of these in here. And that same jumpsuit. He's all about that jumpsuit. Okay, so notice the title of this is Operations with Polynomials in Several Variables. Operations with polynomials in several variables. Would you like me to interpret that for you? I'm sure you would. It basically means the same crap you've been doing, okay? The same stuff we've been doing with terms that have more variables in them. So for instance, if I had in multiplication of polynomials here, if we had x plus 3 times x minus 7 in section 4.5 or 4.6, today in section 4.7, I'll do this in a blue pen here. So this is 4.5 and 4.6. In 4.7, we would have like x squared y minus 3 times x squared y plus 4. Okay, so notice that this term right here has two variables in it. So operations, add, subtract, multiply, divide, with polynomials, these are polynomials, in several variables means that what we were doing with one variable, and here we do it too. Nothing changes. We're going to learn how to do this particular problem right here. In fact, we'll write that one over here. X squared y minus 3 times x squared y plus 4 to do later. If you can't see that in the camera, don't worry about it. It's more for me to reference. Same thing. Sorry I keep clearing my throat. It's been something going on for a while. Oh, Let's hope it's not. Yeah, exactly. Add, subtract. Same kind of a concept here on stuff like this. If in section 4.4 we had, x squared minus 5x plus 6, let's see, whoops, we want to say plus, 2x squared minus 7x minus 2. We're adding those two polynomials. Now we might have like x squared y minus 2xy plus 7 minus, so subtraction of polynomials, 2x squared y minus 4xy minus 8. Again, if we compare the terms, you'll see these multiple variable combinations. That should make sense to you, all right? So I'm going to erase that real quick. That explains what we're doing in this section. All right, so let's get rid of all this. Shot of the back of Brother Rich's head. It's something you guys have a lot of this semester. Okay, so you're on page 371 with me. Part A, so we talked about this. Again, in section 4.7, we're reliving the basics, okay? And if we look at part A, they ask us to evaluate the polynomial, all right? And if we're going to evaluate the polynomial, now they're giving us polynomials where instead of x, like for instance in section 4.3, I had you evaluate the polynomial x squared minus 5x plus 6 when x equaled -1. And we plugged that back in. If you remember that, we did that, okay? But right now what I want you to do, you can look at problem number 7. xyz squared, xyz squared minus z. Minus z, okay? And they want you to do this when x equals 3, y equals 2, or -2, and z equals -5, okay? So if we come in here and we look at this x, where there's an x we put in a 3, where there's a y we put in, yep, a -2 in parentheses, and a z, we're going to have -5 squared, and then it's going to be minus, and again in parentheses, -5. And we talked about this. Z is -5, so we have to put a parentheses around that, and that minus is part of the formula. We have to obey the order of operations right now. And so we're going to have 3 times -2 is -6. Nope, we're not going to do that yet. Okay, we're going to come back to that. We've got to do exponents first. Okay, so we're going to have 3 times -2. -5 squared is going to be -5 times -5, -5 times -5 right there. And that's going to be positive 25. And then minus -5. Okay, minus -5. Now we're going to multiply and divide from left to right. Okay, so we don't have any parentheses in the sense of operations, in the order of operations. These just mean multiply. Or we're separating the minus and the negative. We talked about that in the past. A real parentheses would be like 3 minus 5. Now we have an operation going inside there. We don't have anything like that, okay? So we're not worried about that right now. So 3 times -2 is -6. And -6 times 25, do that on a calculator, you're going to get -150, okay? And then that'll be minus -5. Minus a minus makes -150 plus 5. And you put that in your calculator and you have -145. Okay, so this is going to equal -145. And that's your answer. So again, nothing new here. You know how to evaluate a polynomial, but these have more variables than what we did in the past. So I think, you should be very comfortable in section 4.7 tackling all the homework in the sense that, you already know how to do these concepts. It's just going to be a little more work because they're involving more variables. Another thing in section 4.7, while you're looking on page 371. We have what we've had in the past, those word problems, okay? They're really not word problems, they're evaluate problems, and they're asking you to evaluate those polynomials. So, for instance, lung capacity. This is a funny one. You look at grandma there, she's got a little breathalyzer on, and they're measuring her lung capacity, right? So in this time of coronavirus, this could be a very real thing going on. Some of you are chuckling looking at that picture. It looks like she might be doing something she shouldn't be doing. I'll let you guys ponder on that another time. That's kind of funny. Okay, so we've got C on that problem right there. This is number 9. Okay, number 9 in your homework. You've got C equals, okay, negative 0.041H, negative 0.041H, okay, minus, okay, 0.0184, okay, I think that's an 8, okay, 0.0184, and then minus 2.69, minus 2.69. And I can tell you, looking at this right now, oh sorry, that's not an H, or a 4, that's an A. That is a big A right there. So we have 0.01, and I can't tell if that's a 6 or an A. That's an 8. Okay, we're good. Sorry, guys. Okay, so this polynomial equation says can be used to estimate the lung capacity, which is C, lung capacity, in liters of a female of height H. Okay, so there's your height. Okay, and age A in years. Use this formula for exercises 9 and 10. So it says find the lung capacity of a 20-year-old woman who's 165 centimeters tall. Okay, I mean, it's pretty straightforward, folks. Number 9, lung capacity, that's C, that's what we're looking for. C equals negative 0.041. They tell you in this problem that you have a 20-year-old woman. Now, age is in years. Okay, and in this instance, A in this problem is going to be what? Yeah, that's right. A is going to be 20 years old. Okay, so A equals 20 in this instance. And height, it says height is given in centimeters. And for number 9, it says her height is, that's right, 165 centimeters tall. I lost my partner, Diamond Dave. He got called out, but he's going to come back and help us out here in a minute. Okay, so this is 165 that we're plugging in there, all right, minus 0.018, and again, this is going to be times 20, and then minus 2.69, minus 2.69. Okay, folks, I'm going to let you guys handle this on a calculator like I do in class. This doesn't require any further assistance from Brother Rich, and you can check out the answer in the back of the book. But the main point is we want, and I'll tell you right now that the answer to this problem is 3.715 liters, okay? So I want you to say it's 3.715 liters, all right? Because your lung capacity is measured in liters. And I want you to do this on your calculator and come up with that. So you can pause right now and you can finish that up. Okay. So this takes care of section A. Again, nothing new there. You guys are good to go. What about part B in section 4.7? Part B. Identify the coefficient and the degree of each term in the polynomial, then find the degree of the polynomial. I'm going to put a problem up on the board here. Number 20, 6 minus xy. Number 20, 6 minus xy plus 8x squared y squared plus 8x squared y squared, and then minus y to the 5th. Minus y to the 5th. Now they're asking us about the basics of polynomials again. They're asking us to identify the coefficient, the degree of each term of the polynomial, and then to find the degree of the polynomial. So first off, everyone, let's look at what is the coefficient. Remember, it's the big number. How many terms are in this polynomial? How many terms? 4, that's right. 1, 2, 3, 4. Terms are separated by plus and minus signs. What is the coefficient of this term? That's right, it's 6. It's always the big number. How about this one? -1. That's right, don't forget the negative. 8 and -1 again. Coefficient, big term. Good job. Okay, now what is the degree of each term in the polynomial? Now, let's go through this. The first one here, this is the one that gets kind of funky. We've talked about it. There's kind of a silent x to the 0 here, right? Remember, degree is the degree of the, it's of the variables in each term, okay? This is the degree of each term. So this first one, the degree is 0, because there is no variable. Now what about the next one? And we did discuss this in class. Sometimes people say, oh, it's 1. Okay, but it is actually 2. If you said 2, you were right, because you have a 1 and a 1, and that adds up to be 2. It is, if we remember, it is the sum of the variables in each term. So what's the next one with that in mind? Absolutely, it's 4. 2 and 2 make 4. Some people say, well, it doesn't add up a degree. Right, but that's the coefficient. Remember, the degree of the term is only of the variables. And then the last one, obviously, is 5. Oh, Diamond Dave is back. We missed him. We missed him, man. All right, now, a couple of my classes, when we were lecturing, I realized on our last day of lecture that we did not go over what the degree of the entire polynomial was. So I want to talk about that for just a second. The degree of the entire polynomial is, and some of you got this, it's the greatest degree of any one term in that poly. Okay, in the entire poly. So we don't add all of these. What's the greatest degree in there? It's 5, right? So the degree of the polynomial is degree 5. That's considered a degree 5 polynomial because the greatest degree of any one term is 5. If it was a tie, for instance, let's say that this wasn't 4, but let's say it was also 5. I know that it, so that would make this like a 3 right here. Okay, 3 plus 2 would make 5. It's still a degree 5 polynomial. It's a tie to the greatest one. Okay, but we never add them all up and say, 5 plus 5 is 10 plus 2 is 12 or anything like that. Okay, let's pause for a second. All right, we're back. So in part C of section 4.7, they ask you to collect like terms. So I put collect LT up here because LT stands for like terms. And again, you totally know how to do this. We talked about this. We gave you an example in our lecture. I just want to go through it rapidly with you. Let's look at this polynomial. This is number 24 in your textbook. We have m to the third plus 2m squared n minus 3m squared plus 3m squared n. Okay, how many terms are in this polynomial? Let's look. We have 1 separated by plus or minus 2, separated by plus or minus 3, separated by plus or minus 4 total terms. And what are the like terms? Okay, so we look at this and we ultimately have, in fact, I'll tell you what I want to do here, just to kind of mess with your brains, all right? I'm going to change that to mn squared. So we have m to the third. Is this an m to the third? It is not. Is this? It is not. Is this? It is not. So m to the third is by itself. It's part of the answer, okay? And then I have m squared n. Is this an m squared n? It is not. Is this an m squared n? It is not, okay? So we're beginning to see there's nothing like that. And then we have an m squared. We already know those aren't them because we've looked. That's not an m squared. So we have no like terms up here, okay? So if we were to add a couple of things to this and say, plus 5m squared n minus 7m n squared, now we have some like terms. So we come back to this, we have no other m to the thirds, okay, we look this, we have no other m to the thirds, that's coming down. We have 2m squared n, again, remember, operations with polynomials and several variables, so again, this kind of thing of there's multiple variables going on in this term. We have an m squared n. That is not an m squared n. Neither is that. This is an m squared n. We circle that. We have 2 of them and 5 of them. 2 plus 5 makes 7 exactly. So we have 7 m squared n's. Okay, and again, we can cross those out so we don't need to look at them anymore. Do we have any other just m squareds? Not here, not here. That comes along for the ride, 3m squared. And then I have 3mn squared minus 7mn squared. And 3 minus 7 makes negative 4mn squared. Okay? And we can look at this again. If we're like, hey, did I do all this right? I have m to the third, I have no other m to the thirds. I have an m squared n, I have an m squared, but no n, and I have an mn squared, there's no squared there. So these are all different terms. This is our final answer, okay? Okay, so still in the same light that everything in 4.7 is a review of things you've done, but with bigger terms that have more variables in them, let's look at this problem right here. So in section 4.4, we learned how to add and subtract polynomials, which I told you in class you already knew how to do because we simply are combining like terms, combine LT, okay, after we distribute parentheses. So 1, we distribute parentheses, 2, we combine like terms. If we had a plus in between these two polynomials, it would be the addition of polynomials. We wouldn't need the parentheses. We've talked about that. I'm not going to do an addition problem and a subtraction problem. I think you guys understand this concept pretty well. This first parentheses in problem number 38, this is the biggest problem in this section. Again, we look at this, we have a 3y to the 4th x squared. Notice that they're putting y's before x's here. They can do that if they want to. We usually put the x's before the y's, but this is what they did. There's one term, there's the second term, there's the third, there's the fourth. Here we have 1, 2, 3, 4, 5 terms, 2 polynomials. They're being subtracted. So we're going to distribute parentheses first to add or subtract these 2 polynomials. Okay? I want to ask you something really quick here. If this was a plus here, right, we would just be adding them. Okay? If there was nothing written in between, they're tightened up a little bit, we'd be multiplying them. Okay? But in this instance here, we are subtracting these. Do we need this first parentheses? Is there a distributor here? Distributor is just 1, so we can really get rid of that parentheses in essence. Okay? And so we've talked about that in the past, and we can just go ahead and say see ya to that. The only thing it does is it kind of does separate what you're doing from one to the other. We do need the minus in this parentheses right here, because it is going to go to here, to here, to here, to here, and to here. So this will end up being, if we were to rewrite all of this, 3y to the 4th x squared plus 2y to the 3rd minus 3y, x, thank you. Diamond Dave keeping us honest here. Let's just do that really quick. 2y to the 3rd x minus 3y minus 7, and then we'll have minus 2y to the 4th x to the square. What does this one become? Minus 2y to the 3rd x. This minus goes here. Minus and minus makes plus 4y. And then minus and minus 2x makes plus 2x. And minus the 5 right there. Minus 5. And now we've got to combine like terms. We've got y to the 4th x squared. We've talked about the symbol method. Is this a y to the 4th x squared? Nope.